Hi there, folks. Today we're looking at some of the special cases for factoring. And once again, these are shortcuts that we're discussing here today. You can still do the first way we learned to factor trinomials, but there might be a little bit, especially in this first one, there's something you have to consider because as you're starting to look at these first couple, you're probably looking at it going, those are not trinomials, Mr. Jansen. Trinomials have 3 terms. Those are binomials because they each only have 2 terms, all right? So if you want to go old school, if you want to factor it without the shortcut we're going to learn, you have to think about those as trinomials, all right? So today's shortcuts, the first one I think is worthwhile. The second one, not so much, all right? When we get to that second shortcut, follow along, do what you can with it. And then if you immediately forget it after the lesson's done, that's okay. I'll forgive you. It's not going to hurt you in the long run, all right? So that's my gift to you today, all right? But if I look at this, the first thing it says here is we want to consider these first couple as trinomials, all right? Remember, a trinomial is of the form ax squared plus bx plus c. And when you look at these are not trinomials. They're binomials. They only have 2 terms. But the reason I wrote the ax squared plus bx plus c is I want us to think about which term is missing. Like, what is missing here that makes this not be a trinomial? All right. And hopefully you're looking at it going, well, it's got the x squared and it's got the number at the end, but it's missing the thing with just x. It's missing the thing in the middle. So if I want to think of this as a trinomial, I basically just fill in the middle. I say, you know what? There's nothing in the middle here. Well, the math way of writing nothing is 0. So I'm going to put a plus 0x in the middle. That's the same thing as not having it there. That's what a 0 is. All right, but now it's written as a trinomial. So now I can do what I always do and build a bridge. So there's a 1 out front, and I build a bridge. That gives me a -4. 2 numbers that multiply to a -4, but add to a 0 is going to be a +2 and a -2. And because this one starts with a 1, I can use the other shortcut that I know and say, hey, you know what? I can go right to the 2 factors. This +2 becomes an x plus 2. And the -2 tells me to write an x minus 2. And I can only use that shortcut because this guy starts with a 1. All right? So that's my answer for this one, and that's it. I'm factoring it as a trinomial. And we haven't even used the shortcut for these particular types of problems yet. All right? We used a different shortcut that we learned. And honestly, you don't even need that. You could split that 0 up into a plus 2x and a minus 2x, and you could factor by grouping, and you'll get the same thing. Okay? These things by putting a 0 in the middle and then factoring the way we've always done it. You don't have to do the shortcut we're about to discuss. However, this shortcut I think is worth trying. Okay? So these problems are called differences of squares, okay? A difference of squares, if you can see it down here. Let me scroll down just a little bit. There we go. I still want to be able to see the examples. So a difference of squares is when we're subtracting 2 perfect squares. So if you remember your perfect square numbers, we talked about those a little bit earlier, but like 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, 25 is a perfect square, 36 is a perfect square. So if you have 2 values being subtracted and everything there is a perfect square, you can immediately factor this into what we call conjugates. And conjugates are basically the same 2 binomials, but with different signs in between. Here's an example of conjugates right here. X plus 2 and x minus 2. It's the same binomial, but each one has a different sign. One's a plus, one's a minus. Here, this one, x plus 3, x minus 3. Those are conjugates because it's the same binomial, but one has a plus and one has a minus. Here, 3x minus 2 and 3x plus 2. Those are conjugates because it's the same binomial, but one's a plus and one's a minus, all right? And so if I recognize it's perfect squares being subtracted, I can immediately go right to the factors, and really coming up with those factors is really just a matter of taking the square root. Like here, you see this guy? It's a 4. The square root of 4 is a 2. See this guy, the square root of 9 is a 3. Over here, the square root of 9 is a 3. That's where I get the 3's from. The square root of 4 is a 2. That's where I get the 2's from. Okay, so we can use this shortcut to factor if we recognize the difference of squares. Okay, for example, if I look at this guy, x squared minus 49. And here's the thing, x squared is a perfect square. It's literally in the title. X squared is a perfect square. All right, so really we just have to worry about the numbers as long as we have an x squared in there. Okay, look for perfect squares, make sure it's subtraction. All right, difference of squares, subtraction of perfect squares. So here, x squared minus 49. 49 is a perfect square. X squared is a perfect square. We have subtraction, so this is a difference of squares. I can go right to the two binomials. When I do the square root, it's x times x will give me the x squared. So ask yourself, what's the square root of 49? What times itself will give me the 49? The answer is a 7. And now, conjugates, just one's a plus, one's a minus. Done and done. And again, if you forget this, put a 0 in the middle. Build a bridge. You'll get the same answer. All right? If you look at this guy, again, x squared is a perfect square. 100 is a perfect square. We have subtraction. This is a difference of squares. So it's going to factor into conjugates. Ready? Square root of x squared is an x. The square root of 100, what times itself gives me 100? It's a 10. One's a plus, one's a minus. That's how we factor a difference of squares. This is the shortcut, okay? X squared minus 81, those are perfect squares, and they're being subtracted, so it factors into conjugates. X times x. 81, the square root of that is a 9, so it's 9 times 9. One's a plus, one's a minus. It factors into conjugates. This is our shortcut. If I look at these guys, let's consider this. Now, this is the special case that it's probably not worth even memorizing, all right? It's nice for me to just show you this special case so you know it exists because it comes up in other areas of math, all right? If this is the last math course you ever take, well, then you know what? This shortcut's definitely not worth it, okay? And for the most part, most students don't memorize this as a shortcut. They just factor it the way they would always factor a trinomial, okay? So like this one. Let's see what it looks like. I build a bridge. So there's a 1 out front. That's a 1 times 1 is a 1. Two numbers that multiply to a 1 but add to a negative 2 would be a negative 1 and a negative 1. See, multiply to a positive 1, add to a negative 2. I can use my other shortcut in this one because there's a 1 out front. So I can go right to x minus 1 times an x minus 1. And what's interesting now this time, see, last time I got the same binomial with different signs. This is literally the same binomial twice, which means I could leave it as this, or I could even write it as x minus 1 squared. So that's what squaring something means. It means I have that thing twice, all right? And here's the thing. If you're factoring this, I'll accept either one of these as an answer, okay? Different situations, we would use a different version of this thing. Sometimes we write the x minus 1 twice. Sometimes we'd write it as x minus 1 squared, okay? We call these perfect square trinomials. A trinomial that basically gives us something squared. It gives us the same thing twice. That's what something squared means, the same thing twice. All right? So a perfect square trinomial always factors into a binomial squared. Okay? The easiest way to identify a perfect square trinomial, some teacher will give you weird patterns where you look at A, B, and C. Remember, A, B, and C are the numbers that we have out front there. But looking at those patterns, oh my goodness, it's tough and it's weird to memorize, and you don't want to do that. The easiest way to recognize a perfect square trinomial is to build a bridge. If you build a bridge and the two numbers you get are the same, it's a perfect square trinomial. Here, if you build a bridge and get the same number twice, it's a perfect square trinomial. Here, you get the same number twice, it's a perfect square trinomial. All right? For example, if I look at this guy, all right, build a bridge. Let's see if it's a perfect square trinomial. I'd be shocked if it wasn't. But there's a 1 out front. I build a bridge. So that's a 25. Two numbers that multiply to a 25 but add to a negative 10 are a negative 5 and a negative 5. And see, I can tell it's a perfect square trinomial because I got the same two values here. So now with that said, if I want to go right to the squared version of this thing, I would just say, hey, in order to get this guy, I would have to take x and multiply it by itself. In order to get this guy, I would have to take 5 and multiply it by itself. And then the last piece of this shortcut is I steal the sign from my middle term. And now I can square it. And I'm done. That's it.